Alright kiddos, let's consider this next video as an addendum to your alkane nomenclature video, which is probably, depending on the numbering this year, is probably 008. This goes along with that. This should be a short little piece, but one of the things that's pretty unique in organic chem, really not in organic chem, just in chemistry in general, is that there are fixed rules for naming things according to the IUPAC conventions that we talked about last week. But then there are also a lot of legacy names or common names. These things have been called this for a long time, for decades or hundreds of years, and we don't just drop those names in favor of the more reasonable, logical IUPAC names. And so what that means is that the deeper you go into chemistry, the deeper you go into science, you have to know the common name for things as well as the actual official IUPAC name. So take a relatively simple halogenated alkane like this, and what you're going to see is that the IUPAC name for this would be 1-fluorobutane. Okay, there's 4 carbons. There's a fluorine on it. That turns into fluoro. It's on the first carbon if we number from the nearest branch, and so that's what that becomes, according to IUPAC rules. However, what is more common for a lot of these halogens, when you have a single halogen and a small alkyl substituent. Remember, an alkyl substituent just means a chain that would be an alkane, except that you obviously have substituted something to it. So an alkane as a substituent means that it's an alkyl group. Okay, and so if we're going to consider fluorine sort of as our base here, then the chain, okay, the alkane part becomes the alkyl substituent. So what happens then is that we're going to change the butane into what we call a butyl group. Now that's not abnormal. We would do that under IUPAC rules. If we had, like, say, a 10-carbon chain that had a 4-carbon chain hanging off of it, it would be a butyl substituent. Okay, so that's not really all that normal. What that means is that our name for this compound, the common name for this though, is going to be butyl fluoride. So if you've got a single halogen, you've got a small alkyl chain hanging off of it, you're going to name it with fluoride being the main part of the name, the halogen being the main part of the name. So that could be chloride or bromide or whatever. Okay, and then you're going to name the alkane part, the alkyl part, as a substituent with the YL suffix on the end of it. Okay, so that seems pretty straightforward. Another way that you're also going to see these pretty commonly is that, and this is a little bit less common, but it's definitely prevalent enough that you will see it, is that we will give sort of abbreviations to a few of these things. So you might see something like a methyl group, instead of written out as methyl or CH3, it's just referred to as Me3. Now, how would that look, if you saw something in the literature or something like that? You might see something like, I'm sorry for the pen marks there, you might see something like MECl, which would mean methyl chloride. Obviously, if it was ETCl, it would be ethyl chloride, or PRCl would be propyl chloride. A really common way, and probably the most common way that I can think of that I've seen this in my career, is to see something called ETOH. And we haven't really talked much about alcohols other than OH is what makes it an alcohol. But this is ethyl alcohol. This is ethanol. And it is quite often actually referred to as ETOH. And so you just sort of need to know a couple of these common prefixes here to go along with your IUPAC names. Now, let's make it slightly more complicated. There are also numerous situations where it matters where something is connected, okay, and that matters all the time in IUPAC naming as well. So for instance, if I had this propyl group here, let's say that I added a chlorine here, okay? So if this was IUPAC naming, we would call this 2-chloropropane. Okay, it's on the second carbon. There's a chloro group. It's a propane group. Or the way that we would probably be a little bit more likely to see it is if we added an alcohol group there, and we would say that it was 2-propanol. But no one ever calls this 2-propanol. And you've heard its name before. If you go into Walgreens and you get some rubbing alcohol, it's isopropyl alcohol is what it's called. It's called isopropyl because this is a propyl group, 3 carbons, and the substituent, or the thing that we're naming, is hanging off of the middle carbon. Okay, and so we're going to call it isopropyl because it's attached to the middle of the 3 carbons. If it was attached to the end carbon, what we would typically call it is N-propyl or N-propanol, because then it would be normal hanging off of the one group. And again, I'm totally with you. It would just make life a lot easier if we just called them their IUPAC names and said, okay, this is 2-propanol, and if it was hanging off of this end, it would be 1-propanol. But that's just not the reality of the situation. You never hear this referred to as 2-propanol. It's always referred to as isopropyl alcohol. And so we got to remember a few of these common names because of that. So, a couple more cases of terms that you're going to see that aren't quite as IUPAC as one might hope, but that you're going to commonly see really often. One of these is sec-butyl. So all of these are butyls because they all have 4 carbons. Okay, and remember, we're treating it as though it were the substituent attached to, say, an alcohol group or a halogen or something like that. So they're all butyl because they're all 4 carbons, and you'll see that they're all in slightly different arrangements. And so it's not only different arrangements, but it's where is the substituent attached to. So if we added our OH here, okay, for our alcohol group, then this would be what is called sec-butyl alcohol. And the reason we would call it sec-butyl alcohol is because the alcohol group, the hydroxyl group that makes it an alcohol, is attached to the second carbon, or really not the second carbon, but the secondary carbon in this butyl group. It's called a secondary carbon because it is attached to 2 other carbons. If it was attached to 1 other carbon, it would be a primary butyl, okay? And that would obviously make it on the end. That would be what we call normal butyl or N-butyl alcohol. Okay, so sec-butyl, secondary, means that it's attached to a carbon that has 2 other carbons hanging off of it. It has to be a 4-carbon chain because it's butyl. Now, when we get into isobutyl and tert-butyl, things seem a little weird because we've been taught in IUPAC to name things according to the longest chain, but these are sort of an exception to that. Remember, this is common names. This is an old style of nomenclature. So in the case of a tert-butyl, tert here stands for tertiary, which means that the carbon that my substituent is attached to, so the thing that is going to be my base in this case, my chloride, is attached to this carbon. This carbon is then attached to 3 other carbons. That makes it a tertiary carbon. And if you remember, we briefly talked about this in class when we talked about just functional groups and amines. We have primary amines, we got secondary amines, tertiary amines, and quaternary amines even. So tertiary means that it is a carbon attached to 3 other carbons. So in that case, this would make this tert-butyl chloride. It's called tert-butyl, which again I recognize sounds a little weird because it's a tertiary carbon that it's attached to. Okay, so those make pretty good sense. Secondary, tertiary, that makes good sense. The one that usually throws students off is this guy up here, and that is isobutyl. Okay, so in this case, we're going to say that our substituent group here is still a butyl because there are 4 carbons, and I know they're not in a straight line that we would give it butane, but remember, this is common naming. And so there's still 4 carbons, much like there were in the tert-butyl or much like there were in the sec-butyl. But in this case, instead of the alcohol or my substituent or my base, depending on what we're talking about here, instead of it being attached to a carbon that is then attached to 3 other carbons, it's attached to what I like to think of as the back carbon. Okay, so instead of it being attached to this carbon as it was in a tert-butyl, we can think of it as being attached to this carbon on the end, the carbon on the back side of the molecule. And so what that means is an isobutyl common group is attached to a carbon that is then attached to the 3-carbon chain that we're used to seeing in a tert-butyl. So, I mean, the question is, like, how can I reason this out every time? To be honest with you, I mean, you could reason it out saying it's secondary and it's tertiary and all that. Really, just the simplest way is just to put these in your brain, memorize them, know how to use them. You're going to see them a couple of times. So, let's run through a few quick examples here, and then I'll try to finish up because it was my intent to make this video as short as possible. So, we're going to give a common name or write the formula for each of the following. Now, what I think is really useful when you've got condensed formulas like these two is actually to write them out before you name them. That just makes life a whole lot easier. And so if we were going to write this one out, and I'm just going to write the carbons on this just to make life a little quicker for us. But if I were going to write this one out, I've got a carbon, another carbon, another carbon, and these are methyls, so I'll put my H3. I've got another hydrogen here, okay, and then the Br is hanging off of this end. Now, why did I bother to write that out? Well, because by writing it out, what I recognize immediately is that my bromine or my bromide is attached to the middle carbon of a 3-carbon chain. So that I recognize now as an isopropyl group. And so that makes this isopropyl bromide. Okay, the same thing I think is going to be especially true over here. If I write this out again, I've got a CH3 connected to a carbon. That carbon has two methyl groups hanging off of it. Okay, that's what the CH3s are. Okay, and then a fluoride as well. And so I look at this weird thing and I'm like, that looks pretty familiar. That looks like something we might have just talked about. That is a tert-butyl. Okay, it's a tertiary. Remember that carbon is attached to 3 other carbons, so that's a tertiary butyl. So that's a tert-butyl fluoride in that case. Okay. As far as naming the others, ET, remember, is ethyl, and so ETCl is just going to be ethyl chloride. Propyl chloride, if we're going to draw that out, it's 3 carbons, 1, 2, 3, with a chloride hanging off of it. Isopropyl iodide is going to look somewhat the same. It's going to have the same structure, except that the iodine is going to be attached in the middle. That's what makes it isopropyl. Okay, and then isobutyl, remember isobutyl is the weird looking one. And so that's the one where I've got the 3 carbons with the back carbon, and that's what my bromine is attached to instead. So remember, it looks like a tert-butyl, but it's a little different. Okay, it's attached to the end carbon instead of the carbon in the middle. Okay, so that's isobutyl bromide. And then a tert-butyl chloride, well, we just did a tert-butyl fluoride up above, so I don't think a tert-butyl chloride is going to be any trouble. And that is going to look like this, okay? And that, remember, again, is different from the isobutyl because instead of being attached to the carbon on the backside, it's attached to that central carbon. All right, guys, I hope that was useful to you, and I hope that you're not too frustrated by doing common names. I know that it would be much easier if we just sort of stuck with IUPAC names, but we got to work with the way the world actually works in regards to chemistry, and so we needed to know those common names. Thanks a lot, kiddos.